Hey everybody, I hope that you're doing well. So we're on to our last section of material. The rest of the course will go we'll take our test next, test 6. And then I'll post a few videos or a few lessons reviewing for the final exam. And then in those I'll talk about the final a little bit more. And so we're getting close to finishing up the course. We should be finished before Thanksgiving or around Thanksgiving, or we will be done before Thanksgiving. So let's jump into today's lesson. Today's lesson is about dividing polynomials. So we have added and subtracted polynomials. Last lesson we multiplied polynomials. Today's lesson we're dividing polynomials. And we're actually only doing 2 varieties of these. And the 2 varieties have 2 different ways of doing them. And so this lesson comes down to dividing by one term. That's one style we'll look at versus dividing by 2 terms. So that's another style we'll look at, either dividing by a single term or dividing by a binomial. Both of them require different ways to attack these. Okay, so we're going to start here, just by dividing by one term. And the idea is, if we're dividing by a single term, we can take it one term at a time. Take it one term at a time. It's kind of like, I hate to say it, but it's kind of like distributing. Okay, and you'll see when we work an example, kind of like distribution, where each term that we are dividing into gets this one division. Now when we move on to this one, I don't even want to spoil it yet. We'll talk about that after we do a few examples of dividing by one term. So let's jump into some examples. So let me give you one. Let's go with 10x to the third minus 5x squared plus 20x. And we're going to divide that polynomial by a single term. Let's do 5x. And so this is what we're talking about with dividing with a single term. Dividing in is just a simple 5x. Now, this is what I mean by taking it one term at a time. And this is also what I mean by it is like distribution. There are 3 terms up top. Does anybody see the 3 terms? It's kind of why it's important to be able to tell what a term is. We talked about terms and polynomials a few lessons ago. So what we're going to do is each term on the top, so the 10x to the third, will get divided by this single term on the bottom. So every term on the top will be divided by the term on the bottom. And once again, the last term, 20x, will also be divided by the term on the bottom. So the way to do these is that all 3, well, it depends. We could give you 5, 10, 15 terms up top. Each term up top will be divided to by the single term on the bottom. And so we've worked problems that look like each single term when we practiced exponent rules. So these are actually quite simple to do. So if I take it term by term, I can do the 10 divided by 5, that's just 2, and x to the third over x. Remember our exponent rules, x to the third over x? This is understood to be a 1. The exponent rule says that's x to the 3 minus 1, or x squared. So that's all we're doing here is the numbers divide and then combine the like bases. This would be 2x squared. Okay, so we've done the first term. Let's do the second term. Let's bring down the subtraction sign. 5 divided by 5 is 1. And x squared divided by x, that is x to the first. So, of course, I don't need the 1. I could make this look a lot nicer just as an x. Okay, now finally the last term. Bring down our plus sign. 20 divided by 5 is 4. And x divided by x, those eliminate. Those divide out to 1. The x's cancel is the word I'm not supposed to say if I'm being mathematically correct, but they divide out to 1, so you're just left with a 4. So there we have performed the division, and there we are. 2x squared minus x plus 4. So doing a division by a single term is not hard. Now let me show you more so what the one on the test is going to be like. They like to involve 2 variables usually on the test. So let's do one more example of dividing polynomials. So 9x to the 6th y to the 3rd plus 12x to the 5th y squared minus 6x to the 3rd y. The third's kind of hurting. Let me make it a little bit neater. There. And all of that is divided by a single term, 3x to the 3rd y squared. Okay? So once again, we have 3 terms up top. See, my term with the coefficient is a 9, the term with a 12, and the term with a 6. And on the bottom, I have a single term. So once again, we are going to consider this as 3 separate divisions. Everybody gets divided by 3x to the 3rd y squared. So let me write this out carefully, being sure not to miscopy any of the terms. Make sure I copy them correctly. Let's see. 12x to the 5th y squared squared over 3x to the 3rd y squared minus 6x to the 3rd y over 3x to the 3rd y squared. Okay, so I've written it out as 3 separate divisions. Okay, so each term up top is being divided by the term on the bottom. So see, a lot of people like this division more than they even do multiplication or adding or subtraction. It's not that hard. So let's do this. 9 divided by 3 is 3. And then I need to combine the like bases. X to the 6th over x to the 3rd means I need to take 6 minus 3, so this will be x to the 3rd. Okay, combine the y's, y to the 3rd divided by y squared. That means I will have y to the 3rd minus 2. 3 minus 2 is 1, so just y to the 1st. I don't need to put the 1 though. Bring down our plus sign. Let's work on the next term. One term at a time. 12 divided by 3 is 4. X to the 5th divided by x to the 3rd. It'd be x to the 5 minus 3, which is x squared. Y squared divided by y squared. Those are gone, right? Okay. Bring down our minus sign. And this last term is where they love to try to trick people on the test. 6 divided by 3 is 2, right? X to the 3rd over x to the 3rd, they're gone. Y over y squared. Remember, this is understood to be a 1. So y to the 1 minus 2. This would be y to the negative 1. And so we did all this talk about exponent rules. I'm not allowed to leave that as a negative exponent. So I need to fix just that last term. The first term is fine, right? Second term is fine. In the last term, I'm going to need to fix this y to the negative 1. Well, remember, how do we fix a negative exponent? We take the base and the exponent and move it from the top to the bottom, or from the bottom to the top. This is understood to be on top of a fraction over 1, so this y to the 1st will go to the bottom and become y to the positive 1. So they like to do that to you on the last problem where you have to fix a negative exponent on a term. Just one term. They won't throw it on every term. So there we go. Okay. So I think besides, this was just like last example, just more variables, bigger exponents, and then this last term had this funny negative we had to fix. But I think we should feel pretty good about dividing by a single term. Okay. Now let's move on. How are we going to do division by 2 terms? This is actually going to take you back to 4th grade. We need to do this. We're going to use long division. I know everybody's jumping for joy because everybody loved long division in the 4th grade, right? Being a little bit of sarcasm there, a little bit of sarcastic. But let's see if we remember how to do long division as a 4th grader. Let's see if I can make up one on the spot here. I don't have one written down in my notes. If we were to do, help me out. Let's do 4 divided into like, let's do 579. I don't know. So how do you do a long division? Well, the step there is to take it. When we did long division way back in the day in elementary school, we said, okay, well, this number obviously goes into this big number a lot of times. So what I need to do is look at one decimal place at a time. So we look at this biggest digit first, and we would ask ourselves, how many times does 4 divide evenly into 5? And we'd say, oh, it goes into it once. So that's the same question as asking, can I multiply 4 by anything to get 5? No. Well, how close can I get? I can multiply 4 by 1 and it would give me 4, and that'd be really close to 5, right? And so we would do this, and then we'd say, okay, well, I need to subtract off something here. What would I subtract off? I would say, okay, we'll take what we just put up top, the 1, multiply it by the divisor, the thing we're dividing by. So 1 times 4 is 4. Put it down here, and the part we couldn't forget is that we would like to subtract that off. Subtract it off. So, okay, right? Y'all kind of remember doing this, and then that would give me 1, and I would bring down the next number, 7. So then I could ask the same. Then I just start the whole cycle over again. I say, okay, how many times does 4 divide evenly into 17? And that answer there would be 4. And we would do the same trick. We'd say, okay, now 4 times 4 is 16. And then I can't forget that I am subtracting this off. And what I would get there is 1. And I would bring down the next digit, 19. And we would keep going with this. We'd say, okay, well, how many times does 4, another cycle, divide evenly into 19? Divides evenly into it 4 times. 4 times 4 is 16. And I got to remember to subtract that off, and that gives me a remainder of 3. Well, now we're out of decimal places, so we can always just do that. Or we could say there's a remainder of 3. We could do that. Don't want to stress you out too much taking you back to the 4th grade. You might have thought the 4th grade was tough. So we would say that, oh, look, there's the remainder. Okay? So here's my good news. If you could kind of muster up the ability to do a long division like you did in the 4th grade, we're going to be able to kind of use this as a model for how to do long division with polynomials. So let me give you an example of a problem you may see. I might tell you to take something like 6x squared plus 19x plus 12 and divide it by 3x minus 5. Okay, so that looks kind of complex, but we're going to want to write it like we did over here, this long division kind of format. So what we're going to do is we're going to take the dividend, that's the thing we're dividing into, we're going to write it over here. I'm going to kind of space it out a little bit, make sure I got plenty of space to work. Okay, so that is the polynomial I'm dividing into. Now let's take the divisor and put it over here. Okay, so this is actually going to end up working very, very much like this long division. Here I did not want to try to think about the whole 579. I wanted to think about the first digit. Here we're going to do the same thing. We're only going to think about this first term. Now, I don't want to try to divide all of this stuff into the first term, so let's just look for the first term here as well. So 3x, does it divide into 6x? And you could do some scratch work out to the side if you wanted to. So the question was, does 3x divide into 6x? And the answer is yeah. What's 6 divided by 3? 2. What's x squared divided by x? X. Oh, that's a horrible x. There we go. So does 3x divide evenly into 6x? Actually, yeah, it does. And that gives us 2x. Okay? That's just what we did here. Does 4 divide into 5 one time? Does 3x divide into 6x squared? We did some scratch work to figure it out. You might could have done that in your head. 3 into 6 is 2x into x squared is x. Or you could do some scratch work, but it's 2x. So far, this is very similar to the long division from 4th grade. What was the next step over here? We took the piece that we had put up top, and we multiplied by the divisor, put it underneath, then we subtracted it off. We're actually going to do that same thing here. We're going to say, okay, 2x times the divisor, so 2x times 3x is 6x squared. Now, we can't forget about the minus 5 when we multiply. 2x times this minus 5 is a minus 10x. Now, so I have multiplied the part of the answer with the divisor and put it underneath. Now, what am I going to do with it? I'm going to subtract it off. So I need to subtract off both of these terms. Now, when I do a subtraction here, 6x squared minus 6x squared, that cancels. Here I have minus a minus. Remember, when you have double negatives, that makes a positive. So I have 19x plus 10x. That gives me 29x, assuming I copied everything down correctly. Uh-oh, I didn't copy everything down correctly. Forgive me. This was looking nastier than I wanted it to be. This is actually supposed to be a minus 19. Whoops. Let's fix that before we get too deep into this. A minus 19x. The ones we're going to give you are nice. This one was looking a little more difficult than the typical we give you, which we could still do that one. It just starts to get a little bit nastier. Alright, so let's see. What color do I want to write with? Let's go back to black. Okay, so now negative 19x plus 10x. So only thing that changed was this number. I had it written wrong. Okay, is everybody with me, hopefully? So we still have this minus 10x, which makes a positive. So negative 19x plus 10x is a negative 9x. Okay? So now we're going to do the same thing over again, same cycle like we did here. After we finished our subtraction, we once again said 4 goes into this number and started the cycle all over again. So 3x, does it divide into negative 9x? And we could do some scratch work on the side. Dividing 3x and just some scratch work. Does it divide in? Well, negative 9 divided by 3 is negative 3. X and x cancel. So yeah, that does divide in. It is going to give us a negative 3. Okay? Negative 3. So a minus 3. Now we're going to do the same thing where we take this term that we just found. We're going to multiply by the divisor, put it underneath, and subtract it off. So negative 3 times 3x is negative 9x. Negative 3 times negative 5 is positive 15. Let me bring this plus 12 down. Alright, so what we're going to do again here is, remember, don't forget, we need to subtract off this and subtract off this. Well, minus minus makes that a plus, right? So a negative 9x plus 9x, they cancel. A positive 12 and a negative 15 makes for a negative 3. Okay? So, I hope you're with me so far. We're going to try to go again, and we're going to notice this is 3x. This term does not have any x's in it anymore. So this one is our remainder. Okay? So we have finished our division. We just need to know how to write our answer now. Alright, so the answer is up here, and then we got to tack the remainder on. So our answer to this problem, our solution, is 2x minus 3. And then what we do is we take the remainder, and we want to say, okay, so here's our remainder. So we write it as a fraction. So what we did was we took this number and divided it by 3x minus 5. This is the piece that was left over that did not get divided by 3x minus 5. So in our answer, we write it as that number, the remainder, divided by 3x minus 5. It's just connected, so this is the remainder part. We could not evenly divide this 3 by 3x minus 5. So it is tacked on for the ride. The remainder goes right there. So there is our quotient, our answer. That is what we did with our long division. We took this, divided it by 3x minus 5. We got 2x minus 3. with a remainder of minus 3. So you set the remainder right there. Okay? So how do you feel? This is very similar to long division back in 4th grade. It followed the same pattern of finding this goes into one digit, multiply it, subtract it off, carry it down. Do your 4 divided into the next thing, but how many times it was divided in, multiply it, subtract it off. It follows the same exact pattern. Okay, so let's do one more. I'll give you a larger one this time, one more term, just so we can get one more cycle in, just for practice, because it's each cycle is the same thing, right? So if I give you one with x to the third, x squared, that'll give us one more time to cycle through to practice just one more, cycle. So let's see. So let's go with 5x to the third minus 4x squared. Let me try to make sure I copy it correctly this time. Plus 3x minus 4 divided by x minus 2. So we're going with a pretty simple divisor this time. Let's see if I can write it all ready for long division here. 5x to the third minus 4x squared plus 3x minus 4. Okay, so there we go. So now we're just going to go about doing our division. So remember, I look at the first term and the first term. That's all I'm going to really use to start the division. 5x to the third. How many times does x divide into the 5x to the third? And you may wish to do some scratch work. How many times does x divide into 5x to the third? Notice I'm grabbing just the first terms. And let's see, 5 is still on top. X squared divided by x is x squared. Sorry, x to the third divided by x is x squared. So for this first division, we get 5x squared. Okay? Now remember, once you get that, what we do is take our term here in the quotient, our answer, multiply it by the divisor, write it underneath here, and subtract it off. So 5x squared times x is 5x to the third, and 5x squared times minus 5 is minus 25x squared. Okay? Now, what can you not forget? We need to subtract off these blue numbers here. So subtract off this term, subtract off this term. Well, 5x to the third minus 5x to the third, that's gone. A negative 4x squared minus a negative, well, the minus a minus is a positive, becomes a positive, makes a positive, right? So negative 4x squared plus 25x squared, that is a positive 21x squared. I'll go ahead and bring down the next term, the plus 3x. Okay, so that is one cycle through this division. So let's do the second cycle. So look at our first term, our leading term here, 21x squared. And we'd like to see how many times x divides evenly into that. 21x squared, how many times does x divide into it? That'll be 21x. So let's see, that's a positive, so plus 21x. Okay? Once again, we're going to take this 21x, multiply it by the x minus 5, and then subtract it off. So 21x times x makes 21x squared. 21x times a minus 5, ooh, that makes a what? A negative 105x. Oh, this one's becoming some large numbers here. Once again, I hope I copied it correctly. Oh, I did copy it wrong. That's okay, we'll keep going. I wrote a 5 there. That's a 2. It's okay. We already started with a 5, so let's just... Man, it's not my day. We'll pretend it's a 5. We'll see what we get. Might be some large numbers here, but that's okay. We'll pretend it's a 5. My bad. This works out to prettier numbers with a 2, but still the same concept, right? So now I cannot forget to subtract these off. So let's see what we get here. 21x squared minus 21x, gone. Positive 3x minus a minus makes a positive. That makes 108x. Let's go ahead and bring down the minus 4. So we're almost done cycling. We got one more cycle to go through here. how many times does x divide into 108x? 108x divided by x. Oh, the x's would just cancel, leave me with 108. So it's a positive 108. Okay, we're going to multiply back, and I may even need a calculator to do this. Let me see if I have a calculator near me. Let's see, 108 times x is 108x. 108 times a negative 5. 108 times negative 5 is going to be a minus 540. Whew. And so don't forget to subtract these off. So 108 minus 108 is gone. A negative 4 and a positive 540, that will make a positive 536. And that is our remainder because we finished, there's no x with it, that's a plain number. So there's our remainder. It's a large remainder because I messed up and copied this down as a 5 and not a 2. My dyslexia just gets me sometimes. But that is correct for a 5. We did the problem. So let's see. So what's our final answer? 5x squared plus 21x plus 108 plus, and let's take our remainder. What is our remainder? 536. It's a large remainder. Divided by, and then what was the divisor? X minus 5. Alright, so there we go. This would be a lot prettier if I were to use x minus 2, but forgive me. Still works. You can still divide. You can divide by anything. It may not be as pretty, but there we go. Okay. So we know how to divide by two terms. We're not going to divide by anything bigger because we're not quite ready for that. You will look at some divisions that may be bigger when you get into Math 111, the next math course, but you're just going to simplify down what they call rational expressions or rational functions. It's just really big things that are big fractions. All right, so that's all I have for you today. So we're looking to test next, and then we'll start talking about the final exam. You guys have an awesome day.